US Physics Olympiad, year 2019, USAPHO, final round. Problem A3. Electric slide. Two large parallel plates of area A are placed at x equals 0 and x equals d, which is much less than square root from A, in the semiconductor medium. The plate at x equals 0 is grounded, and the plate at x equals d is at fixed potential negative V0, where V0 greater than 0. Particles of a positive charge Q flow between the two plates. You may neglect any dielectric effects of the medium. Part A. For large V0, the velocity of the positive charges is determined by a strong drag force, so that V equal mu E, where E is the local electric field and mu is the charge mobility. Question 1. In the steady state, there is no reason but time-independent density of charges between the two plates. Let the charge density at position x be rho x. Use charge conservation to find the relationship between rho x, Vx and their derivatives. Question 2. Let Vx be the electric potential at x. Derive an expression relating rho x, Vx and their derivatives. Hint: start by using Gauss's law to relate the charge density rho x to the derivative of the electric field Ex. Question 3. Suppose that in the steady state conditions have been established so Vx is proportional to x power b, where b is an exponent you must find, and the current is non-zero. Derive an expression for the current in terms of V0 and the other given parameters. Part B. For small V0, the positive charges move by diffusion. The current due to diffusion is given by Fick's law, I equal negative AD multiplied by d rho over dx, where d is the diffusion constant, which you can assume to be described by the Einstein relation, d equal mu kBT over Q, where T is the temperature of the system. Question I. Assume that in the steady state conditions have been established so that the non-zero steady current flows and the electric potential again satisfies V proportional to x power b prime, where b prime is another exponent you must find. Derive an expression for the current in terms of V0 and then other given parameters. Question B. At roughly what voltage V0 does the system transition from this regime to the high voltage regime of the previous part?